So here we are again. I have these old analog instruments, and yeah, from a complete teardown of my very first power supply. Very nice instruments. That one has a little hiccup in that the dampening, the internal, isn't working so well. That one is absolutely fine. And yeah, I have a piece of Perfboard that goes on the screw terminals on the back, and the plan is here to build something like that on the Perfboard. So I have some screw terminals and fixed resistors and some multi-turn trimmers just for adjustment, and yeah, that's important for analog instruments. A protection diode that should limit the voltage here in any case to 0.6, 0.7 volts. You could go lower, but I don't have the parts, so that goes in a very simple diode. Yeah, and that's it. That should give me then an analog instrument with two ranges, 25 volts and 4 volts, matching the scales on these things. No focus today, sorry, shit happens. Yeah, and one of them will be the voltmeter, obviously, and the other thing will become, this is a little bit more convoluted, the ammeter with two ranges, 400 milliamps and 2.5 amps, and the circuit on the Perfboard is basically the same. Yeah, two trimmers and two fixed resistors, and just checking are these values right. Yeah, they should be right. But in addition, and this is something I might want to try now, the instrument I'm using as ammeter, it was used as ammeter in the old power source, and there was a reason for it, and the reason is this only needs 25 microamps or 120 millivolts for full scale, while the other one needs 200 millivolts for full scale, and that would require, and this is a convoluted part, forget about it for the moment, that would mean I had to choose much bigger shunt resistors, and I didn't want to do that. So yeah, and this capacitor here should provide some dampening. Second, so remember that instrument? Nothing happens anymore. It's absolutely stable. And the trick here, it's really just a trick. I have put a 100 microfarad capacitor across its terminals. And the trick here is this is a kind of a electromechanical dampening, because I mean the inside of such an analog instrument is nothing else but kind of a electric motor. I mean, you have a coil inside a fixed magnetic field, and of course it cannot turn 360 degrees because the needle has to work against some force of spring force, mechanical spring force. But anyway, if the needle wants to wiggle, which it doesn't do anymore, if the needle wants to wiggle, it has to turn the motor, or in this case the generator, and the generator will induce voltage. And as soon as I put a load on this generator in form of this capacitor, the magnetic field will induce a counterforce. That is, the magnetic field, the current going now through the coil of the instrument, will induce a magnetic field in the opposite direction and generate a counterforce. And yeah, it's dampened. And this is not a trick. If I take that one off, it will wiggle like crazy again. And with the capacitor on, where's the screwdriver when you need one, huh? With the capacitor on, it's dampened. That simple. And we are inducing here only a few hundred millivolts at most. So yeah, a full scale instrument here is 200 millivolts. So basically the dampening will only induce 50 millivolts, 100 millivolts, something like this. And even if this is an electrolytic cap, it should survive that. Yeah. So now I will solder my components on here and on the perf boards. But I don't think you need to see that. It's too complicated for me today to solder around the camera. Oh, and before I forget it, I also made a layout of the whole thing, just, you know, to be sure it's fitting all on the perf board. And yeah, I clipped some holes in it to see that it's really fitting on the instruments beforehand. And here we have the finished product. The resistors, fixed resistors for the lower and higher amp range, so 400 milliamps and 2.5 amps. The trimmers for the lower and the higher range, the protection diode, and yeah, the 100 microfarad 16 volt. It's enough. If there are ever 16 volts here, the instrument is dead. Capacitor and yeah, a little screw terminal. And yeah, not nice, but it works. Simply bend most of the time the leads of the parts to form the traces, and I used here actually some, yeah, this is copper wire with a silver coating, and made loops around the contact places, the contact holes, and yeah, let's see, we still have the non-damped instruments, and I should be able to, so I have to put that down. Camera is on a step ladder. If you haven't seen that clip, link and a card somewhere. And if I'm lucky, this should now all fit together quite nicely. Oh, bullshit. Yeah. Doing such things in front of the camera always leads to disaster. I do it offline. This is a little bit fiddly with the washes. Okay, I actually managed to screw it on, and yeah, from the top when they are in the case, they are very nicely available for yeah, tuning in the instrument, because these are all 5% resistors, and yeah, and of course the capacitor is its dampening thing very nicely. Okay, so next instrument, I guess. Oh, the next board. So, sorry, focus. Better. Next board is finished. It's basically the same like the first board, only the values of the pots and the resistors are different, and of course the capacitor is also missing. I don't need it here, same technique, because obviously the damping in that instrument is still working absolutely fine. And now it's also mounted on the back of the instrument, so yeah, we have two now. And the next thing to come into focus, what's that? Oh, it's only, yeah, some lead from some part. Oh, sorry. The next thing to come into focus is thank you, is this convoluted thing here. And basically this is a double switch, double throw. So yeah, two changes here, and yeah, it's a bit convoluted because I've drawn it in a way that I know how to solder it. But what it's basically doing is we come from the positive of the power supply, and we go always through this 0.33 ohm resistor, which will accordingly feed the... Oh, did I make a mistake here? So it should feed the 400 milliamp range. And if you flip the switch, I have to be careful, I have to correct that. And if you flip the switch, like in, no, everything is fine. Like in this position, like it's drawn, you have in parallel this 0.07 ohm resistor. And yeah, the whole thing goes obviously to the positive binding posts, and these will be the shunts for the ammeter. And this is only the resistors on the ammeter are only dropping something in the millivolt range. Okay, this is really just for yeah, for adjustment of the tolerances of all these resistors in the instruments itself, and for adjustment to the resistor values I had available or I could buy on a reasonable price. And yeah, let's solder that thing here together. It will be not nice. So I finished this construction. The range switch for the ammeter. And yeah, that was, come on, focus. That convoluted part. And as I said, it's basically the current is always flowing through the 0.33 ohm resistor. And if you put the switch in the high range position, that is 2.5 amps, the 0.07, no, that's not right. It's another value, I guess. Or maybe it's 0. The smaller resistor is put in parallel, so your shunt is lower. And it produces at 2.5 amps about the same value, the same voltage drop. You have the same voltage drop as with just the big shunt resistor at 400 millivolts. And the second part of the switch, or the second pair of contacts, is simply used to get that signal to the two inputs of the revamped ammeter. And yeah, and this should go to the power supply, and this should go to the binding post, to the positive one. Did I do that right? Yeah, I think so. We'll see. So that's, oh, come on, focus. Sorry. So that's the last of it. It's really just, I mean, a range switch with a lot of wires attached to it, so I can supply ground and either one or the other input of the instrument, of the voltmeter, with the with the output voltage. Yeah, that's it. Okay, you see down there, I already started putting together, and now that all parts are there, we should play a little bit with it and calibrate the instruments. So, I've put everything into the case, also from the strap power supplies. So we have the 25 microamps ammeter with a range switch above it. Yeah, it's a tight fit, and of course there's currently nothing, no power supply attached to it, but that comes in a second. And the 40 microamp instrument has also its range switch attached, which is rather simple and primitive. I mean, it goes into the board, and plus and minus go to the binding posts, and yeah, that's all. And of course, the input from the output from the linear power supply goes through the shunts and then to the positive binding post, which is yellow, but inside. But yeah, I have to work with what I have available right now. So, and to alleviate our little power problem, we simply connect this to the power supply. There should be a hole in the binding post. Yep. And the negative goes to, I loop that around to the negative binding post. And my instrument, we put that on volts for the moment. We measure the output voltage, which we dial down because we don't want anything to blow up. And I have a small screwdriver. So let's see. Yeah, we have some reaction here. Let's go to the, first problem. One range is showing nothing. That's not nice. Okay, let's try the 25 volt range. And I only come up here to 13 volts. Yeah, that's a bit of a bummer to adjust it, but yeah, let's try to dial that to exactly 13 volts. Oh, okay, near enough. And adjust the instrument to 13 volts. Now, which pot will that be? Yeah, it's the right pot. Okay, and I'm at the end of the scale. And obviously, I made some miscalculations here. But I have to check that board out anyway. Why it isn't working correctly. Okay, that's a little bit of a bummer. But not to worry. We still have the ammeter to have some fun. And okay. Let's go here to the amp range. And connect in the load with just one lamp. I don't know where to put that, so it will be in the shot and we'll see what's happening. Oh, that was the 400 milliamp range. And that's supposed to be the 2.5 amp range. So yeah, I have 0.6 amps now. Oh. That's not good, is it? Let's dial that down a little bit. Oh, no, with the amps, let's do it the other way around. Use the 10-turn pot. So 0.6. And there's obviously a bad connection. You see that? That's a 400 amp range, 400 milliamp range. And this should be the You see that, don't you? There is obviously something wrong with that fucking switch. And I'm wondering, see that? Yeah, that's no good. That's absolutely no good. And I wonder if the same is wrong. On this side. Oh shit. Well, shit happens. This seems to make absolutely no connection whatever. Okay, back to step 1. I'll try to debug the whole thing. Okay, I fixed the issue with the voltmeter. That was just, bad soldering on my part. And this is the high range, and we go to the low range. That is 0 to 4 volts, and we have about 4 volts. That's the best I can do with that thing at the moment. And we try to adjust it. Let me see. Am I blocking the shot? No. Yeah, that works like a charm. So, 4 volt range, full scale, and this should go back to too much. Obviously, we just go up to, what can we do, 15? Let's do the 10 volts. About-ish. Yeah, I can't dial it down any further. I only can dial it up. It's not so good, is it? But why? I mean, according to my calculations, I should drop over a 560k resistor at 40 microamps 22.4 volts, and over the pot at 540 microamps 0.4 volts at 100k. Does that pot have? But yeah, this resistor is not right. I don't know. So 560k times 40 microamps is millivolts divided by 1000, 22.4 volts. But I don't get 22.4 volts. I mean, it's already at 15 volts here. Let me do some more research. Yeah, me stupid. The resistor values are, if you read it right, absolutely fine. So I'm dropping here the bulk of the voltage. I have some adjustment. And yeah, I'm dropping not 40 voltish, but 25 voltish. Because the upper range is clearly 25 volts. So if you read the lower scale from 0 to 25, and yeah, that's a drawback with analog instruments, from 0 to 25, yeah, we are exactly, and I should be able to adjust that a little bit. Yeah, we are spot on 10 volts. Yeah, okay. But yeah, so this range switch should work like a charm. Okay, 4 volts, and then let's see what we can do. 10 volts. Yeah, 13 volts. That's all I get out of that contraption at the moment. So yeah, voltmeter. And ammeter, that's another story. Yeah, let's connect the ammeter through a load again and dial down the current. And dialing down the current, I get a higher voltage, 28 volts. Yeah, something is definitely wrong with my breadboarded contraption there. So I can actually go up to 25 volts, can I? Ooh, that's not very stable. Yeah. $25. Yeah, good enough. And Jesus. $25. Just have to look at it the wrong way or come near it. So yeah. So a little over 25 on the high range. So we give a few turns more. 25.99. Yeah, that's it. And yeah, that's what I talked about. This is plus minus 1.5% full scale. if I go down again to the 10 volt mark now, we are already at plus minus 3%, and it's spot on 10 volts, but now we are, yeah, 10 millivolts off or so. Yeah. Okay. Ammeter. I'm on the high range. Okay, nothing bad can happen. We're going to the amp range. And we put my electronic load into the loop. Okay, we are on the low range and the switch shouldn't have any influence. And now we can try to go up to 40 milliamps. I need some voltage for that. 400 milliamps, sorry. Too much. Yeah, 399 and yeah, almost spot on. That's the lower range. I can adjust that a little bit. Yeah, but when we go to the high range, 2.5 amps, yeah, that's the switch making contact. But yeah, okay. So I need a working switch for that. Oh yeah, this is just rolling around. Yeah, okay, that's what you get for, if you saw the mailbag video for link, for buying crappy switches. But yeah, I guess I will have to buy some quality switches for the amp range. Otherwise, yeah, that's not working. Okay, next try. So, yeah, I measured these switches from eBay. I think €1 per piece or so. That I used in here, and on the ammeter side where really current is flowing, I mean they were specified with maximum contact resistance of 20 milliohms, but they had a few hundred milliohms, and yeah, if you actually just touch, wiggle a little bit here, it varies a few hundred milliohms. So yeah, these things just shows, yeah, there are some markings on it. Yeah, they were too expensive for even one piece of buck, especially when you think that at least one of them came out of the bag with one pair of contacts already defective, not really switching. And yeah, I replaced them with these. I don't know if there's a brand on there. Yeah. And yeah, the differences are obvious if you see how much metal is on here. But also if you look at the back, here the pins are simply in the plastic, seated in the plastic. So as soon as you heat them up for soldering, they start to wiggle if you're not very careful. Here the pins, they are set in a special, I think, more heat resistive substance. And yeah, also I put them to my microphone. So that is the China switch. Switching it. And sorry, zooming out again. And that is the $4 a piece switch. Yeah, talking about decisive switching action. And yeah, so I replaced that one on the current side. I eventually will replace that one too, but yeah, that's somehow working. That wasn't working at all. So let's try it again. Okay, we need some kind of ammeter. Okay, we need power. Okay. And now we need some current. No current is flowing. Why not? Because my load is off. Oh. Did you see that? So now I'm... Okay, there's obviously still a problem. That should be the 2.5 amp range. And obviously... I was wrong about the resistors, huh? Yeah, shit happens. Let's try to adjust the high-end side. Oh, this should be 2 amps. Okay, so this is obviously too much. Okay, the 400 milliamp range is perfect, and yeah, switching also is perfect, and the dampening is perfect, but my resistor value is not perfect. And yeah, I would like to know what we are actually dropping here. Just a second. Okay, I hope we're finally there. I actually forgot to solder yeah, one of the wires correctly. Oh, I didn't solder it at all. I just you know, threaded it through the hole in the pin, and I forgot about it. And when we're talking resistances, the smaller shunt is 0.07 ohms. Not soldering a connection and just having metal on metal, yeah, doesn't work. Now it's probably soldered and it works, and you see low range 370 milliamps, upper scale, not making the same mistake like on that side, and yeah, let's go to the higher voltage range and give a little bit more. Yeah, 400 milliamps going to the upper range. Yeah, it's still not, yeah, half amp. Okay, now let's tune that up to 1.5 amps or whatever I can provide here. 0.6, another resistor. Oh. And another. Yeah, that's good enough. Let's try to tune that in on, oops, yeah. On 2 amps. Yeah, I guess that's good enough. And now let's try if the range can be tuned here sufficiently. It's all over the place, huh? And I'm turning it in the wrong direction. Why is it still a cold solder joint here somewhere? Oh no, it's actually a little bit fluctuating. Yeah, okay. Maybe I should hot glue all this stuff in here. Just not hoping it gets hot. Yeah, there's a slight changes if I bend the cables and so on. So yeah, a lot of hot glue and a lot of zip tie to make it mechanically sound. But there you have it. Sorry, 2 amps, 2 amps on the higher scale, and okay. Sorry, off, and yeah, let's turn that down to 400. Yeah, 400 milliamps on the lower range, and yeah, this is actually rock solid because the switch is now not involved. And yeah, there's something for you to learn here too, because my principle of switching the shunts via a switch is that's a quite crappy construction, because as I said, my shunt is 0.07 ohms. Switch resistance for good switch, which that is probably 0.01 ohms, so 10 milliohms, so 70 milliohms to 10 milliohms, and switch resistance might change over time. So yeah. Can we make it wiggle? No. But the switch is good, it's rock solid. So, perfect. And yeah, that's finally it. End of project with the 2 hiccups, bad switches, bad soldering on my part, but yeah, you can actually use analog meters. Would anybody use nowadays analog meters? No. This is just, I don't know, from my youth. So I wanted to keep the analog meters, and yeah, and they were, as I said, they were good analog meters in that time, but yeah, it will be a usable power supply. But if you build a new one, take digital meters. Not the one for $3.50 from eBay, though. Okay, bye.